Okay, so multiplying and dividing in scientific notation is a little different than adding and subtracting. I think it's actually a little easier. You do not need the numbers to have matching exponents beforehand, so you don't have to use Lars to manipulate the numbers at all beforehand. You just multiply and divide the coefficients, and then you use two of our exponent rules, the product rule and the quotient rule, to multiply or divide the 10 to the exponent. I'll demonstrate. And then afterward, you use Lars to convert your answer back into proper scientific notation by making sure the coefficient is between 1 and 10. So I'll give an example. Hi, Luca, I'm recording a video real quick, and then I'll get to your question afterwards, okay?
All right.
So I'll show an example of multiplying and dividing in scientific notation. Say I have the numbers 3.2 times 10 to the 5th and 2.5 times 10 to the 7th. And I want to multiply these two numbers. So the first thing is the numbers do not need matching exponents. So I don't need to worry that one is 10 to the 5th and one is 10 to the 7th. I don't have to worry about that. I can just multiply them. So first, I'm going to multiply or divide my coefficients. So these are multiplying. That's what I said the problem is, 3.2 times 10 to the 5th multiplied by 2.5 times 10 to the 7th. So first, I'm going to multiply my coefficients. So 3.2 times 2.5 is 8. And so we'll call it 8.0. So that's 8.0. I multiplied my coefficients. That was 3.2 times 2.5 equals 8. And then my next step is I use the product rule when I'm multiplying or the quotient rule when I'm dividing on my tens. So in this case, I was multiplying. So the product rule tells me that if I have matching bases to two different exponents, I guess it can be the same exponent, but matching bases to an exponent, and I multiply them, I simply keep the base the same and add the exponents. So here, I would keep the base the same, it's times 10, and then I add the exponents. So 5 and 7 becomes 12, and my answer here is 8.0 times 10 to the 12th. So 10 to the 5th times 10 to the 7th becomes 10 to the 12th. And my number is 8.0 times 10 to the 12th. And then since my coefficient is between 1 and 10 already, 8.0, I don't need to do anything about it. I don't need to use Lars to move the decimal. So that is multiplying in scientific notation. I'll show us dividing real quick. We'll do 1.4 times 10 to the 3rd divided by 2.0 times 10 to the 5th. Okay, so first, it doesn't matter that my exponents aren't matching. I can just dive right in. I'm dividing this time. So I guess I will put the line in between, boom, to show it's dividing. 1.4 times 10 to the 3rd divided by 2.0 times 10 to the 5th. So first, I divide my coefficients. I do 1.4 divided by 2, and I get 0.7. So I've divided my coefficients right there. I then use my exponent rules. In this case, since I'm dividing, I use the quotient rule on my tens. So the quotient rule tells me that if I have a number to the exponent, to an exponent, divided by that same number to an exponent, I subtract the exponents. So in this case, I have 10 to the 3rd divided by 10 to the 5th. So I take 3 and subtract 5. So first I had 1.4 divided by 2 equals 0.7. And then I have 10 to the 3rd divided by 10 to the 5th. So I'm just going to subtract my exponents, equals 10 to the 3 minus 5, or 10 to the negative 2. So I get 0.7 times 10 to the negative second. And then my last step is I got to use Lars to convert my answer into proper scientific notation to make sure that my coefficient is between 1 and 10. So right now, my coefficient is not between 1 and 10, smaller than 1. So I need to move my decimal so that it's behind the first non-zero digit. So I'll move it once to the right. Using Lars, when I go to the right, I subtract. So that becomes 7.0. I subtract 1 since I went to the right once. And it becomes 7.0 times 10 to the negative third. So that is how you divide in scientific notation.